Thank you very much. Good morning, everyone. Great to be here. And Steve has really teed me up nicely to talk about this next section. So thank you very much, Steve. I'm going to try and make this a little bit interactive, okay? So I will be asking you questions at key points as we go through, and we'll do it old school, sort of show of hands, okay? Okay with that? Firstly, just kind of a brief introduction to Eco2. We've been around for 16 years now, and our main focus, or our reason for being, is to help decarbonise critical environments such as clean rooms, laboratories, and so on. So we work a lot within the pharmaceutical life science sector, but some of these concepts are equally applicable to other types of clean rooms, and we'll talk through those. So we work with lots of life science companies all around the world, and we have a little bit of fun doing what we do as well. So topics for today. So about three things. So I'm going to take you on a little bit of a journey through, and I know the headline of this is about dynamic control ventilation in clean rooms. We will get to that, but there's kind of a little bit of journey to go on to get to that, and you'll see kind of how we've arrived at the next step, the future of clean rooms as we see it, and how that's evolved. And a lot of it relates to what Steve was talking about in the previous presentation as well. So why we're doing it, around environmental topics, key hot topic at the moment, and critical for our futures really, and also for business. And I'll talk through what you can do today, and then also kind of what you can do in the very near future as well, and some technology. Right. First thing is around, you'll be aware. I think last year carbon emissions globally rebounded to the highest level ever after a slight dip following the pandemic. And you'll be aware all the various COP meetings and so on and so forth. Governments and agencies are really struggling to get to grips with this. But actually what we see is businesses are taking action on this topic in quite a big way. What's clear from a lot of research that's gone on, and we talk a lot about net zero carbon zero, getting to that in whatever time frame we want to put on that. What is very clear is that energy efficiency is absolutely a key enabler to net zero. 30 to 50% efficiency improvement is what we're going to need to see on existing building stock. Okay, that's because the way we're growing our energy use, I'll show you on the next slide. Our global energy demand is increasing hugely. You can see up 20% from 20 years ago. Right. Now some of that is being offset by efficiency improvements and different ways of doing things. But the middle blue line there is kind of, we haven't really changed our actual energy consumption over that period. And that activity line is going up all the time. We're doing more things, we expect more of our energy infrastructure. Something's got to give. And the efficiency part is absolutely key to this. And not only that, if you kind of look at energy costs and things like that, just look at air quality in the environment around the world. Now, it's not too bad here in Singapore. I think you've got quite a good record of making good improvements, except when you get your neighbours kind of burn down plantations and things like that. But pictures from India, okay, pre-pandemic. On the left there, in Delhi, smog is very common. Lots of cities around the world have that. A large part of that is related to industrial energy use and energy generation, as well as motor vehicles and all that kind of stuff. Yet, right-hand side is kind of during the lockdown in India, chalk and cheese, very different. If you think about the life science industry, we're in the business of improving people's lives and well-being and health, right? Yet, if our activities are contributing to a poor environment in which people are living and breathing that air, how is that beneficial to people's lives? So think about kind of bigger picture stuff, and just trying to set in the context of why we do what we do, and why it's important that we all, as an industry, kind of maybe can take some steps on this. I'm going to show you how. So, first question for you. Show of hands, please. Does your organisation, the organisations that you work for, have targets around environmental performance or energy use? So, if yes, stick your hands up now, please. Okay, fair few. No? Anyone vote for no? Fair enough. And anyone not have a clue? Well, that must be the rest of you, surely. There's only 3 possible answers. Okay. All right, bit of a difference there. But, okay, so goals are important, right? The only thing we want to achieve in life, we need to set targets. If we don't set targets, then how do we know we've done what we set out to do? So, let's talk about now, kind of particularly bring it back to clean rooms specifically. So here's a clean room, fairly typical. This clean room is around about 150 square metres. Standard recirculation, so it's kind of low amount of outside air, just the outside air needed for pressurisation, and that will be costing anywhere in the region, particularly in this region, 100 to 200,000 Singapore dollars, 300 to 500 or 600 megawatt hours a year of energy. Okay, so kind of a reasonable expense, not a very big room. You take a room this size, you'd be talking $1 million plus Singapore dollars to operate. This is a fairly low grade clean room because of a huge amount of air. But in terms of, when we look into detail this clean room, kind of looking at and breaking that down a little bit, 3 to 5% lighting, sometimes less, depends, if you've got good lighting control. Quite a small amount actually. LED lightings work really well, really efficient, more and more going in all the time. You'll have some miscellaneous power needs, right, balancers and computers maybe and things like that have a bit of a draw, 3 to 5%. Pretty small beer, small stuff. The process is kind of quite variable. So we've got a soft wall isolator in here. It's actually not that energy intensive, and the reason is, quite often this one, but you might have a more energy intensive process like granulation or compression or something like that. Quite a lot of the time you find that in pharmaceutical facilities, most of the time in the clean room, not a lot is going on actually. The actual process manufacturing part of it is a relatively short amount of time generally. We're either cleaning, we're either setting up, we're qualifying, we're doing all of these other necessary activities. The value add of making product is quite short, and actually then you're running the equipment for a short amount of time. So the main user, as you're probably aware, is creating the right environments, moving the air, conditioning, dehumidifying here. Huge energy demand, okay? 50 to 80% easily of the whole energy use. depends on the amount of outside air. Right? Higher grade clean rooms use potentially more outside air, but certainly more air volume. We're moving air around much more quickly. And as Steve was alluding to, maybe that's perhaps not, we don't need to do it as much as we have done in the past. So I referred to the top, at the top about 30 to 50% reduction in energy intensity or energy use in spaces of what we're going to need. And here we have different types of facilities have slightly different kind of energy demands because of the nature of what they do. It's highly variable. It's also related to where in the world you are to a large degree, and what kind of products and what conditions you're trying to create. But it's very clear that they're big numbers in terms of intensity, and there's small improvements. So the blue bars there are showing kind of what we could achieve with application of best technology. Green bars are what we typically see, and we've done a lot of work with organisations to kind of incrementally improve things. But basically, we're going to halve that in the future if we've got any chance. So it's a big effort. Part of the process again is getting down into the nitty-gritty. Where is that energy used on a particular site? A manufacturing facility will do lots of things. Not only clean rooms, but it's clean rooms where most of the energy is consumed. An office is kind of not really that energy intensive, not particularly interesting. But it's the clean rooms where we're looking, and you can see there. Again, this particular site in Vietnam, very similar climatic conditions to here. We see HVAC 60%, and this is fairly typical for an oral solid dose, non-sterile manufacturing site. Aseptic will be a bit more, for HVAC probably. Laboratory, we're looking at laboratory, might be 80%. HVAC, okay, and a lot of that is to do with the volume of outside air that we're using. So, another question for you coming up. So, as we get into the next topic of what can you do now. So, show of hands, please. I'm going to show some different options in a moment. So. What do you think, use your best guess, you think the opportunities are and the potential, we'll look at percentages that you could reduce your clean rooms or the clean rooms that you're familiar with without compromising quality, because that's the key aspect. Steve was talking, we need to deliver these key environments, but how can we do, assuming we can, how much do you think is possible? Do you think it can't be done and we're wasting our time? Anyone want to put their hands up for that? No? Okay, we're on a roll. Good. 0 to 10%. Anyone vote for 0 to 10%? Come on. Nobody? Oh, 1. Thank you very much. 0 to 10%. Very good. That means that the rest of you are 10 to 20%. Anyone going 10 to 20? Okay, that's about half the room, I reckon. Anyone going higher? 20 to 40. Thank you, sir, at the back. And so here. So yeah, we've got 3 or 4 there. So a small number. Anyone more than 40? Wow. Okay. Connor, Tim, Steve, you didn't put your hand up. All right, okay, very good. Okay, well, we've got some really optimistic people here. Okay, so thank you for that. It's really interesting. Most people are in the kind of 10 to 20, should be achievable, right? 10 to 20%, with a few more optimistic. Let's have a look. Now, luckily, we've got a guide to help us. Steve alluded to this earlier. ISO 14644, Part 16. If you're really interested in this topic, get yourself a copy of this. It's great. You know, Steve contributed, Connor contributed, I wrote a little bit here and there. And, you know, again, what's in it? Yeah, it's a process to folk. Yeah? It's a process, a structured process, and we like that kind of structured processes in what we're trying to do, particularly in regulated industries. Great. Quality, love it, because it's a process. It's written down. It's an international standard. We can follow it. Yeah. Debunks this air change rate myth. Again, Steve alluded to that. Air change rate is not the most important factor. Yet they're hugely important for energy consumption. Hugely impactful if you get them wrong. Either way. Okay. But particularly we don't tend to err on the side of caution and make them too small generally. We add multiple layers of safety factor to make sure we've got huge amounts of air. Lots of useful examples and calculations and things like that. So it's great, a great document, highly recommended. If I were to boil it down into its kind of philosophy, if you like, and approach, this was written before Part 4. So Part 4 has added even more to this, which is fantastic. So we want to design and build our cleanroom facilities with efficiency in mind. Okay. Think about that as we're doing that, and Part 4 is set up that really, really well. And then we put them into operation, we see how they perform in reality. And it doesn't mean that we have to leave them exactly like that all the time. We use that operational data to tune the performance. And we gain confidence in our facilities and what they can achieve so that we can optimise them a bit further and not compromise those critical factors. So, what can you do? Highlighted in bold there, the simplest or the biggest thing you can do is just reduce the amount of air that you're processing through these clean rooms. And the amount of air I'm talking about is, I hesitate to say it, I'm not going to say it quickly, air change rate, but I'm going to say supply air rate. Okay, supply air flow rate into the space, but also outside air. So outside air. We need outside air for pressurisation. Quite often we deliver much more outside air and we leak it into various parts and we don't recover it, but we can also optimise that. And as you come down the hierarchy, the saving amount, if you like, kind of can be significant as you get down, but it can also reduce, but also the investment increases generally. That's how it works. So just dialing things down, simplest and easiest to do, very straightforward, rebalance, and requalify, of course, and then you've tuned your systems. Reducing the amount of conditioning done on that space. How often do we, deliver 40% relative humidity to a space, right? And we maintain it at that plus or minus 2%, right? All year round, and yet we don't really need that from a comfort point of view. We're perfectly happy at 50%, 60%. Might need it for product, and that's fair enough if we need to create that environment for product. But it's also worth challenging, do you really need that, or are we delivering it just for people comfort when we're trying to drive things a bit too much? Same with temperature. Condition efficiently, there's also things you can do there around outside air pre-treatment, fans and motors that are efficient. Quite a lot of our facilities are very old, okay? They have old technology fans, or belt-driven fans. You never put a belt-driven fan in now. You put direct drive probably EC motor, depends if you get the pressure. But yeah, the fan technology has improved dramatically over the last 10 years. So can we upgrade those older facilities to be a bit better than they are today? Maintain that efficiency over time, and ultimately what we're delivering is a much better spaces, much more robust, and ultimately, better compliance at the end of the day, because we've tuned them, we've understood how they perform, we understood where our boundaries of possibilities are, and we make sure that we're always operating firmly within that. Okay, so where's the evidence to support what I'm saying? Okay, so back in 2011, some time ago, we did an experimental piece of work because we were really interested, together with AstraZeneca and GSK, to really understand, well, what is the impact of air change rates on cleanliness in clean rooms, and is it important? So we took a facility and we really ran it hard. We had lots of people in the room at the time. We kind of really challenged it. And what we found is that as you reduce air change rates, so this is a grade C room, grade C room, you can see the compliance limit for grade C there. As we reduced the air change rate, as we moved left to right, we saw the average particle concentration, particle counts kind of increase. Okay, interesting. But much more interesting is well within the compliance limit for the space, and it was a marginal increase. It wasn't that big a deal, wasn't that interesting, didn't even hit an alert limit or anything like that. And we see the same for 0.5 micron and 5 micron. And this has been replicated, and this has been shown to be the case on good performing clean rooms. A poor performing clean room, then you want to be careful. So you want to really understand that you've got something that kind of really works okay before you start messing with it. Really, messing, that's a bad word, but optimizing, let's say. So that's sort of non-viable. Viable particulates, because most people ask, well, we can measure particle concentration really easily, really quickly. We can see whether something's working or not. But what about micro? It's really important to me, and we can't tell that immediately because we have to wait 7 days. Okay, now that's another topic that others have spoken about yesterday. But just doing fixed change air rate reduction has absolutely zero impact on microbial air contamination. You can see there that there's a couple of air change rate reductions, supply air reductions from 40 to 30, from 30 to 16. You can see before and after variability in the micro counts, none of which got anywhere near any alert limit, and inherent variation in the process of monitoring micro contamination. Now, what else do I want to say? Yeah, so the micro contamination we've shown is really there's absolutely no correlation to the amount of air we put into a room. It's well correlated to gowning, what people are doing in the space, their activity levels, and that kind of thing. Okay. So, putting all those concepts together, and kind of when you look at holistically at a site, as we've done multiple times, and here in Singapore, just in terms of the themes and kind of opportunities that we see our clients have in front of them. So here's an example. and as you can see, most of the saving opportunities from that tuning and just getting a bit more focused on what that clean room is trying to do and to also make it work better. Big opportunities there. $500,000 is that? Singapore dollars, something like that, per year, every year. So you do this once and you get the benefit year after year after year. And actually it's better than that, because as the energy price increases, you get more and more of a benefit actually over time. Some of the things, supply air reduction, 35% supply air reduction in terms of volume flow rate. When you do that, you have there's a cubic relationship between the amount of air that we supply and the power taken to deliver that air. So if we reduce air by 10%, physics tells us we will get almost a 30% reduction in the power needed to move that air, fan power. So you imagine a 35% reduction, you're going to have theoretically 95% reduction in power. You don't get that practically because other inefficiencies come into play. But there's big numbers, and you change things a little bit, it has a big impact. Outside air pre-treatment, I'm sure you're familiar with this. We dehumidify the air before we mix. Okay, so should be very, very common here, and normally is. But you still find facilities, even here in Singapore, that don't have this concept. The historical legacy things, you can go and fix them, retrofit fresh air, outside air pre-treatment. You reduce cooling by about 40%. You probably eliminate most of the reheating in that 100% reheating, take that out completely. So there's some relatively straightforward things that have a big impact if you start looking for them. Okay, and critically, no impact on compliance, quality, or any other aspects. Okay. So I think this is the final poll question I'm going to ask you now, and you can put your hand up to as many of these as you like. Okay, we'll step through them. So if you're kind of interested in energy, reducing energy in your clean rooms, maybe you've tried to do some in the past. Okay? What do you think the main barriers that you've experienced on this are? So, compliance or quality, perhaps not agreeing with it. Who's experienced that as an issue for them in their objectives? Thank you, a few of you. Resources and skills. This might be kind of availability of resources or skills, or your own skills and confidence. Anyone want to put their hands up to that? Yeah, okay, a few. Money, budget. Okay, a few more hands. Okay, so we haven't got the money. I'll come back to that one in a minute. Management just don't care. Nobody's really interested. Anyone experience that? No? Okay, that's good then. Oh, one. Okay, most of you okay with that. Time. Just don't have the time for it. Right? Okay. Other. Anyone got any other suggestions? No. Okay, we'll leave it. Okay, so a few hands went up there, but most people didn't put their hands up, so I'm assuming then that everything's fine and you can go on with it. But of course, it is difficult doing this stuff. So, come back to budget. Just pick one example. You're already spending the money, of course, because you're already paying the energy bill. Okay, so this stuff pays for itself, and pays for itself in quite a short time. You're talking 1 to 2 years. A lot of these things you get your investment back. 3 years it's particularly expensive to do what you want to do. But, it's that kind of order. It's not too much. So, a few minutes left. So, I'm going to come on to the last topic now, is kind of where the future lies, okay? So, Steve kind of led into this quite well in terms of, when we're talking about designing of clean rooms, determining how much air we need into spaces. We'll do our basis of design to understand all those various inputs, and we'll come up with a number for a flow rate. And that'll be, we'll have that forever. We'll set up, we'll balance our clean rooms, and that's how it'll operate. And of course, then you put it into operation, you put people in it, they come out of it, they go for lunch, they go home in the evenings, process runs or it doesn't runs. So you see that the contamination level in that clean room will vary over time. We put a fixed amount of air in all the time. The emissions rate will change, and so we'll have this variability. And normally what you find is there's a huge safety margin. The evidence, some of the slides I showed on the particle concentration before show that. We've got a real example on the right hand side there of that grade C clean room is operating better than grade B in operation limit. 97% safety margins. We're only operating 3% of the class limit. We've got 97% of safety factor. I would suggest that's probably too much. Maybe we could kind of operate it 20%. So we've got 80% safety margin. If you're really super confident, maybe halfway, you go halfway. Maybe we could get to 50% of the class limit. We'll still have plenty of headroom. But being conservative, 20%, let's say. So and this is reasonably typical. We see this around the industry. Everyone wants the cleanest clean room. Yeah, you can have the cleanest clean room. Do you really need it? And what are you paying to have that privilege? So we start to look at this slightly different way. Look the other way in terms of how can we vary the flow rate based upon the contamination level that's occurring at any particular time in the space. So we can easily measure particle concentration. We can measure rapid methods to measure microcontamination if we want as well. At the moment we're just focusing on particulates, and we're controlling to a set point on the compliance limit for the space. So we're saying, I don't really want to go above 20%. But you can have that at 50%, you could have it at close to the limit if you want. And the flow rate varies. But we're still controlling those critical parameters. We're controlling differential pressures, and we're controlling temperature and humidity, and oxygen levels might be relevant, amount of outside air. Because we're controlling pressure, we can vary the amount of outside air. Sometimes, in some regions, not here, but in Europe, in the winter time, it might be advantageous to have more outside air because it's cooler and you need that cooling load, so you can offset mechanical cooling. You can't do that in a fixed way, or you can, but people don't like to do it. But you can with this kind of dynamic control because you have to have that capability of maintaining that pressure. So we built a facility in the UK. So this is the first facility in the world to have this kind of technology. Cambridge Pharma, they wanted a highly efficient clean room. It's a suite. It's designed for cytotoxic filling. It's not operating as a cytotoxic facility at the moment, but it's grade C background to isolator, sort of clean room, all the support functions around it. quite a nice size of facility, and it's fully dynamically controlled, the whole lot, and it's working really well. And in terms of performance, we're seeing, typically, a poor performing kind of facility, aseptic facility like this, maybe up around 1300 kilowatt hours per square metre, something like that, sometimes higher. Typically around about 1,000. Really good practice one, well designed, that do exist, around about 500. We're seeing the facility that we've designed in Cambridge, much less than that. And then we put dynamic control on top, and it's third. So compared with a typical facility, we're looking at 80% reduction in consumption because of that variability. So Steve was saying, if we did that, 80% reduction in flow, we talked about recovery time, right? So recovery time is important, and if you have too little air, you can't recover in a reasonable amount of time. 2 points that I would make is, in the regulations, it's recovery from typical in-operation condition to an at-rest condition, right? What I showed you before, in terms of that massive headroom, our typical in-operation condition is much, much less. Already, it's not far off. It might even be at the in-operation condition or the at-rest condition for that room, as it was in the example I showed. So we're already pretty good at that. The other point I would make is, with the dynamic control, you don't need to worry about recovery rate, because you're constantly recovering. You don't have that issue of recovery, because if the room needs more air, it gets more air. If it doesn't, it doesn't. That's the whole point. Demand-based response is responding to what's happening in the space, having trend of data on that to tell you what's happening in that space at any point in time, and tuning consistently the operation of the HVAC system to suit what the room needs. So my last slide is just summing up, we can do quite radical improvements in clean rooms if we want to, and I would argue it's kind of benefits business, people, and our customers and consumers of the products we're manufacturing. Safety, GMP compliance absolutely can't be compromised, and doesn't need to be. If you're doing this kind of thing, it's always helpful to engage someone that has done it before, knows what they're doing. I'm one, but also there are many others as well who have done this kind of thing before and know what they're doing. 14644, get a copy, have a read, follow that process. And the future absolutely aligns with the contamination control strategy, the push for the regulators seeing towards technology helping assure that CCS and assure quality ultimately at the end of the day. And with that, I'm done. Thank you for your participation in indulging me in asking questions. Now it's your turn to ask me. And another plug for the CCN. If you fancy signing up, you can probably scan the QR code and get directly to it. Thank you.
Very good.